Good morning, friends. In today's topic, we will discuss about Lambert cosine law. Now, to know about Lambert cosine law, we need to understand few definitions. So, we will start with that. First is solid angle. What is solid angle? The solid angle is a measure of space enclosed by a conical surface with a vertex of cone whose apex is at center of dA1. So the apex of that cone, this is the cone, and the apex of cone is at a surface dA1, and whose area is dA1 related to the total space of sphere of radius r. The length or the distance between two area, that A2 and A1, is r. This is the A2 area. Now the d omega, or a solid angle of this cone, is A2 upon r square. A2 is the area of second surface, and r square, r is the distance between these two area. And the unit of this solid angle is st radian. St radian is represented by SR. So this is the solid angle. If radiation is transferred from one area to another area, we can consider one cone for that, and the solid angle of that cone is d omega A2 upon r square. Now if we consider two area dA1 and dA2, so radiation is transferred from 1 to A or 2 to 1. So if the radiation is transferred from 1 to 2, then solid angle d omega is equal to dA2 cos beta 2 r square if it is at some angle. In previous case we saw that the area 1 and area 2 are at a straight distance. There is no angle or angle between their both axes. If this both area at angle, then we can write area as dA cos beta if the radiation is transferred from 1 to 2. If radiation is transferred from 2 to 1, then we can write solid angle d omega is equal to dA1 cos beta 1 upon r square. Now next definition is intensity of radiation I. It is defined as the rate of energy leaving from a surface in a given direction per unit solid angle per unit area of emitting surface, normal to the mean direction in a space. So we know the energy emitted per unit area is dE, and solid angle we discussed, it is d omega. So the intensity of radiation, the equation for intensity of radiation I is equal to dE upon d omega. Now we are going to start Lambert cosine law theory. So what is Lambert cosine law? Here you can see one figure in which there is one surface, and this is the normal of that surface. So what is Lambert cosine law says? The intensity of radiation in any direction is proportional to cosine of angle made by that direction with the normal. So this is the normal, we represented it by in, and if we consider this direction and the angle between this direction and normal is beta, then we can say I is equal to in cos beta. Intensity in that direction is intensity in normal direction into cos beta. Beta is the angle between the direction and a normal. Now we will discuss another theory that we have to prove this I is equal to pi in or I is equal to pi eb. So we know the I is dE upon dW. From that we can write dE is equal to I into dW. Now I is equal to, according to Lambert cosine law, I is in cos beta d omega. Integrating in both direction we get dE, integration of dE is equal to integration of in cos beta d omega. This is equation number 1. Now from the definition of solid angle we can write d omega is equal to 2 pi cos 2 pi sine beta d beta. So this we put in equation number 1. So we get d is equal to integration of I cos beta 2 pi sine sine db. Now integration of left hand side is e, and right hand side we can get pi into n is the constant, so we put in this side and integration of this all value. Now we have 2 cos beta sine beta. For that we can write sine 2 beta. Now integration of sine 2 beta is minus cos 2 beta upon 2. The range is 0 to pi by 2. We are putting this limit, so we get minus 1 upon 2. So 1 plus 1 or minus 1 is 2. So this is cancel out. So finally we get I is equal to pi in. And the total emissive power of diffuse surface over hemisphere is equal to pi times of intensity of radiation. Thank you.